Unit 7, Bonds, Introduction to the Measurement of Interest Rate Risk, Lecture 8, Duration Measures, Part B. So now we're going to look at an example. We're going to start by calculating the modified duration. So we have a 10-year 13% semi-annual bond with the yield to maturity of 11.5% and a Macaulay duration of 7.5 years. Using the formula for modified duration, we're going to divide the Macaulay duration by 1 plus the yield to maturity over 2 because we're looking at semi-annual payments, and we end up with a modified duration of 7.0922, and we will use this to estimate the percentage price change. Now we're going to move on to calculating the percentage price change for a 50 basis point change in interest rates. And looking at our calculation, it works out to 3.546%. A basis point is 0.01%, which is why we multiply the 50 by that to convert it to a percentage. So what this indicates is that the bond price should increase because we're looking at a decrease in yields by approximately 3.5% for a 50 basis point decline in the yield to maturity. What this means is that if the price of the bond was $949.24 before the decrease in interest rates, after the decrease in interest rates, it'll be 3.546% higher, which would make it $982.90. Since all of your assessments will be multiple choice questions, this is an example of how this particular question can be asked in a multiple choice format. We're now going to look at effective duration, which is the duration measure that is used primarily for bonds with embedded options, but can also be used for option-free bonds. And it includes the value of the bond for an increase in the yield of delta Y, the bond price for a decrease in yield of delta Y, and the initial bond price and the change in the yield. Combining all of this, calculate the effective duration. Now I'm going to look at an example on how to calculate the effective duration. We have a table with 3 bonds, X, Y, and Z. We're given their prices at various yields. We're going to be focusing on bond X. It has a par value of 100, an annual coupon of 6%, and a yield to maturity of 6%. We would like to calculate the effective duration for a 0.5% change in yields. So looking at X, the price at 5.5% is 102 and the price at 6.5% is 98.5. So for a 0.5% change in yield, this bond has an effective duration of 3.5 years. Now all the bonds X, Y, and Z have the same coupon, so if you want to do the calculation for the rest of them, please do. It'll give you practice. Now again, we go to looking at trading strategies, and here using modified duration. So if you expect a decline in interest rates, then you want to increase the average duration of your portfolio in order that you will benefit from maximum price increases. And if you expect an increase in interest rates, you want to reduce the average duration of your portfolio to minimize the price decline or decreases. So here we have an example using duration measures and trading strategies. You expect a decline in interest rates and you must choose between 2 portfolios of bonds with the following characteristics. Portfolio A has an average maturity of 10.5 years, while Portfolio B has an average maturity of 10 years. Average yield to maturity for A is 7% and B is 10%. Modified duration for A is 5.7 years and for B is 4.9 years. So they want you to select the best portfolio and give your reason. Now looking specifically at the duration measure, you would select Portfolio A because it has a longer duration, 5.7 versus 4.9 years, and this should offer you greater price appreciation when compared to Portfolio B. Now the thing I did not mention, which is actually available in the previous slide, is that Portfolio A is non-callable, but Portfolio B has a deferred call. And we know that when interest rates are falling, there's a greater possibility that a bond will be called. So here you want to go with Portfolio A as well, because there's no danger of it being called when interest rates fall.